Hey guys, today we are looking at 2.1, which talks about average rate of change and secant lines. So we're starting by talking about what the average rate of change is. So the average rate of change, gives us an idea. So it gives us an idea on whether or not our graph is mostly increasing or decreasing on a given interval. And actually, I'm going to be a little bit more specific. Instead of saying graph, I'm going to say whether or not our function values. Because sometimes it won't be looking at a graph. Sometimes it'll be looking at a table instead. So we can represent this formula with our slope formula that we're kind of used to seeing. So we can represent it as f of b minus f of a over b minus a, and that's going to be on our interval from a to b. So that's the change in our f of x over the change in our x values is kind of what we're looking at here. So consider the linear function f of x is equal to 2x minus 1, whose graph is shown right here. Find the average rate of change of f of x is equal to 2x minus 1 from 0 to 1. And then we're also going to find our average rate of change from -1 to 2. And what do these averages tell us about our function? So I'm going to start with my first interval from 0 to 1. So that means I'm looking at f of 1 minus f of 0 over 1 minus 0. So looking at my graph, f of 1 is 1. So 1 minus f of 0 is -1. So 1 minus -1 over 1 minus 0 is just 1. 1 minus a -1 is really 1 plus 1, so that's going to give me 2 over 1, which is just equal to 2. And then let's look at our second interval. For this one, we're looking from -1 to 2. So I'm looking at f of 2 minus f of -1 over 2 minus a -1, so 2 plus 1. So f of 2 is going to give me 3. Minus f of -1 is a -3. And that's over 2 plus 1, which is 3. So our top is going to give us 6 over 3, and that's going to give us 2. So notice our average rate of change is the same for both of our intervals. And so what I'm going to say here, and when it asks what do these average rate of changes tell us about our function, I'm going to say that the rates of change are both positive, so the function is mostly increasing on both of our intervals. All right, let's look at number 2, where it's talking about a table. So using the table, we're going to find the average rate of change from 0 to 2, and then our average rate of change from 3 to 4. So my first interval is from 0 to 2, so that means I'm looking at f of 2 minus f of 0 over 2 minus 0. Well, f of 2 is -3 minus f of 0 is 5 over 2. So -8 over 2, which gives me a -4. Then my next interval is from 3 to 4. So I'm looking at f of 3 f of 4 first. Let's do the bigger one first. F of 4 minus f of 3 over 4 minus 3. So I'm looking at a -11 minus a -7, so plus 7, over 4 minus 3 is 1. And -11 plus 7 gives me a -4 over 1, which is just -4. So my first interval was -4, and my second interval was -4. So for both of these, they're negative. So I'm going to say that the rates of change are both negative So instead of saying r, let's say the function. So the function is mostly decreasing on both intervals. Okay, so what do you notice about the rates of change from above? So if we're looking at this example, they were both -4, and this example, they were both 2. So for both of those, the rate of change for both intervals was the same. So this tells us the functions are linear and have a constant rate of change, because when we looked at multiple intervals, we had a similar rate of change, and by similar I mean they were exactly the same. So we have a constant rate of change there, which means we're looking at linear functions. And so when you're looking at linear functions, the average rate of change is simply the rate of change, which is our slope. So now we're going to look at some average rate of changes of functions that are not linear. So what we've been doing so far is kind of been our algebra finding our slope. So now let's look at what happens when we're not looking at a linear function. So for this one, we have a quadratic. So this says, consider the quadratic whose graph is shown. Find the average rate of change from 1 to 3, from 2 to 5, and from 2 to 4. And then talk about what these average rate of changes tell us about the function. So we're going to do from 1 to 3. So I'm looking at f of 3 minus f of 1 over 3 minus 1. So over here at f of 3 is a -4. F of 1 is 0, so -4 minus 0 over 2. So -4 over 2, which is just -2. Then my next interval is from 2 to 5. So I'm looking at f of 5 minus f of 2 over 5 minus 2. So f of 5 is 0 minus f of 2 is -3, so that's going to end up being +3. 5 minus 2 is 3, so I'm looking at 3 over 3, which gives me 1. And my last interval is from 2 to 4. So I'm looking at f of 4 minus f of 2 over 4 minus 2. Well, f of 4 is -3, minus f of 2 is also -3, so that ends up being +3 over 4 minus 2, which is 2. So 0 over 2, which gives me 0. So as you can see here, on all three intervals, we got a different average rate of change. So what I'm going to come and say is that the graph is mostly decreasing, or sorry, let's say function instead of graph. I keep making that mistake. The function is mostly decreasing on our interval 1 to 3. It's mostly increasing on my interval 2 to 5. And on my last interval, it's increasing and decreasing equally because we have an average rate of change of 0. And so you can kind of see that because when I go from 1 right here to 3, my function's decreasing. When I go from 2 right here to 5, it's mostly increasing. It does decrease a little bit, but most of that section of the graph or that section of the function is increasing. And then when I look at my blue, which goes from that same point at 2 right there to 4, if I were to draw a line, it's just straight across right there. And so you can kind of see how we're finding our average rate of change. So number 4, given the function, find the average rate of change from 1 to 5 and interpret what that tells you about the function. So I'm going from 1 to 5. So that means I'm looking at f of 5 minus f of 1 over 5 minus 1. So I'm going to come up here and I'm going to figure out what f of 5 are and f of 1 are, just to kind of speed up this process a little bit. So if I plug in 5, that means I'm looking at negative 5 squared plus 4 times 5 minus 1. So that's a negative 25 plus 20 minus 1. So that's going to give me a negative 6. So I'm looking at negative 6 minus, and then when I plug in 1, negative 1 squared plus 4 times 1 minus 1 gives me a negative 1 plus 4 minus 1, which is going to give me 2. So I'm looking at 6 minus 2 over 5 minus 1 is just 4, and that's a 2, not a 6. So negative 6 minus 2 is going to give me a negative 8 over 4, which gives me a negative 2. So I can say that f of x is mostly decreasing on my interval from 1 to 5 because my average rate of change is negative. And let's look at number 5 right here. It says find the average rate of change of f of x is equal to 3x minus 2 on my interval x to x plus h. So I'm looking at x to x plus h. So that means I'm looking at f of x plus h minus f of x all over x plus h minus x. So let's simplify this a little bit, and those x's cancel out. So I'm looking for the f of x plus h minus f of x over h. And for some of you, this might look familiar, this kind of little formula right here. We're actually going to talk about it a lot in the next video. But let's go ahead and use our f of x function and go ahead and figure out what the average rate of change on that interval is going to be. So that means that I'm looking at 3 times x plus h minus 2 minus my 3x minus 2, and that's all over h. So I'm going to distribute my 3. So that gives me 3x plus 3h minus 2. And I'm going to distribute my negative. So minus 3x plus 2 all over h. My 3x and negative 3x and negative 2 and positive 2 all cancel out. So that means that I'm looking at 3h over h, which then those h's cancel out. So that means that I'm looking at 3. My average rate of change here is 3. And now we're going to kind of talk about when we're finding the average rate of change, that means that we are finding the slope of a secant line. So a secant line, I'm going to draw an example over here. So I'm going to say that this is my x-axis, this is my y-axis, and I've got my curve that looks like this. My secant line is going to be a line that goes through my curve exactly twice. So it's going to touch right here and right here. And so now what we're going to start talking about are tangent lines. And so if I have that same kind of graph, so it kind of looks like this right here, my tangent line is going to be a line that touches this at exactly 1 point, and only 1 point. So the shift that we're about to make, our secant line finds our average rate of change. So it finds our average rate of change. A tangent line is going to find an instantaneous rate of change. And so you'll see those referred to a lot, average rate of change and instantaneous rate of change. And it's really important that you know the difference between those two. The average rate of change is our slope formula that we have been dealing with for most of these notes already. The f of b minus f of a over b minus a. The instantaneous rate of change is what we're going to start talking about a lot more in our next video. We got a couple more examples that we're going to look at. And these are examples of old AP test questions. So this one says, suppose an object's position measured in meters along a straight line at time t in seconds is described by this equation right here. What's the object's average velocity between the time 0 and 3 seconds later? So we're trying to find our average velocity. That means that we are going to try and find our average rate of change. So if we're looking at our interval from 0 to 3, that means I'm going to do s of 3 minus s of 0 over 3 minus 0. So s of 3 is going to be 3 squared minus 5 times 3 plus 1. So 9 minus 15 plus 1. So that's going to give me a negative 5. If I'm looking at s of 0, that's going to be 0 squared minus 5 times 0 plus 1. So that's just going to give me 1. So negative 5 minus 1 over 3 minus 0 is 3. So I'm looking at a negative 6 over 3, which is going to give me a negative 2. And then we need to make sure that we put some units on that. So we're talking about position in meters and times seconds. So I'm going to do that as meters per second. Okay, let's look at 7. For this one, we are going to use a calculator because we've got some decimals. And so it says a rock is thrown straight up with an initial velocity of 20 meters per second and from initial height of 2 meters. The height h of the rock after t seconds by the equation right here. What is the rock's average velocity during the first few seconds of flight? So average velocity means we're using that average rate of change formula. And the first 2 seconds means that we're looking at from 0 to 2. So I'm going to do h of 2 minus h of 0 over 2 minus 0. So h of 2, when you go through and plug it into your calculator, I'm going to give you guys a second to do that right now. All right, so for h of 2, you should get 22.4. And we also need to find h of 0. So you guys plug that into your calculator right now and find it. And h of 0 should give you 2. So I'm looking at 22.4 minus 2 over 2 minus 0. So I'm looking at 20.4 divided by 2, which is going to give me 10.2. And my units are going to be meters per second. Okay, we have one more example that we're going to look at. So example 8 says that concert tickets went on sale at noon, and that's t equals 0, and were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function, L, for 0 less than or equal to t less than or equal to 9. Values of L of t at various times t are shown in the table. Use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30 p.m., so at t equals 5.5. Show the computations that lead to your answer. Include units of measure. So we're trying to estimate the rate at which the number of people waiting in line was changing at our time t is equal to 5.5. So what we're going to do is we're going to look for points on either side of the 5.5. So I know that that 5.5 is going to fall in between my 4 and my 7. And I'm going to use my slope formula that I've been looking at. So what I'm going to do is I'm going to use this point. So I'm going to have my 150 minus and my 7 minus. And then I'm going to use this point as my second point. So I'm looking at 150 minus 126 and 7 minus 4. So 150 minus 126 gives me 24. 7 minus 4 gives me 3. And 24 divided by 3 is 8. So our number of people waiting in line was changing at a rate of 8 people per hour. So that's kind of a slow moving line. All right, for your homework, you are going to have a 2.1 homework worksheet, and we're going to try something different for this unit and see if it helps us out a little bit. So we are going to be using GoFormative. It's linked in the Google Classroom. So make sure you go through and you complete that GoFormative homework.